Our topic is RS latch with control input. Now this is a function table of the RS latch with the control input. On the left side we have inputs E, S, R, and on the right side we have the output, next state of output Q. If we give zero state to the enable input E, S and R are the don't care condition, then at the output we have no change, that is the previous state remains unchanged. Then we give one state to the E input which enables the two NAND gates on the input side, and we give S and R is equal to 0 state. At the output we have no change, that is the previous states remains unchanged. Then we give one state to E input, S is equal to 0 state, R is equal to 1 state, and at the output we have Q is equal to 0 state, which is the reset state. Then we give S is equal to 1 state, R is equal to 0 state. Then at the output Q is equal to 1 state, which is the set state. Then we give E is equal to S is equal to R is equal to 1 state. And at the output we have Q is equal to 1 state and Q dash is also equal to 1 state, which is not possible because if Q is 1 state, then Q dash must be equal to 0 state, because these two are opposite to each other, and that is why this is a unused state. Now the circuit diagram of this latch is drawn. In this circuit diagram, on the left side we have two NAND gates. Input of one is S and the input of other is R, and an enable input E, which is given to these two NAND gates, which enables these two gates. And if one state is given to E, then both these NAND gates on the left side becomes enable, and therefore the state given to S and R will be passed through these gates, and then according to the state of S and R, the circuit set over its output state. In order to avoid the unused state, we can use another latch which is called the D latch. It is also called transparent latch, and in this circuit we can avoid the two unused state, because inverter is connected between S and R. So if S is 0 state, then R must be equal to 1 state, and both the inputs will not in the same state. So the 0 state is given to the D input, and this 0 state passes through the circuit, and at the output we get 0 state, that is Q is equal to 0. So the input state passes through the circuit, and that is why it is called the transparent latch. And if we give one state to the D input, this one passes through the circuit, and at the output we again have as one state. Now the circuit diagram is drawn. Before the circuit diagram, we have its function table. On the left side, we have inputs E and D. E is the enable input and D is the input of the circuit. And on the right side, we have output, which is next state of Q. If E is zero state and D is don't care, so at the output we have no change. The previous state remains unchanged. If we give one state to E input and zero state to the D input, then at the output Q is equal to 0, which is the reset state. Then we give one state to E and D input, and at the output we get Q is equal to 1 state, which is the set state. Now its circuit diagram is in this circuit diagram. D is the input and inverter is connected between D input and the gate, NAND gate. E is the enable input, which enables the two gates on the left side. And then on the right side we have the basic latch, which is the cross-coupled NAND gate. So the function table can be verified by this diagram.